We're going to do more about unit circles, and we're going to look in particular in this video at obtuse angles. This video builds on earlier work, so this is not the first video on this topic. Just remember, an obtuse angle is one that's between 0 and 180, excluding those two values. If we go back to what we've learned earlier on, we've seen this thing called a unit circle, which is a very useful device we use with trigonometry. And we can see that in quadrant 1, which has got the little Roman numeral 1 between 0 and 90 degrees for theta. You can see a little triangle there, and the triangle is right angled triangle. And of course, for that triangle we can use regular triangle trig. So sine theta is something we can find, and it's opposite over hypotenuse, and the opposite is the y coordinate, which we call y1 in this case, because we're looking at point P. Okay, and the red, remember from previously, the red line is the radius arm, and it's moved anti-clockwise from that point 1, 0, and it's traced an arc up to where it is now at P, and that's got points x1, y1. Okay, we've seen that previously. That makes an angle theta, and because the point is x1, y1, the distance vertically that's been traced out is that you can probably just see it there, the green line. Let me see if I can zoom in for you, and so you can see it better. And the green line would basically be the y value, and the x value would be going across. And so opposite over adjacent, opposite over hypotenuse, I should say, for sine, would be y is the opposite. Now what's the hypotenuse? It's a unit circle, so it has a radius of 1, and we've seen before that that just comes out as y. So the y coordinate, or the y distance, is the same as sine. In this particular case it's got a little name 1, but that's just a name. Okay, so that's because there's going to be a second point up there soon, and we can likewise repeat that for cosine or cos, which is adjacent over hypotenuse, which is x over 1, so it's basically the x value, and tan is opposite over adjacent, and we can do the same thing for tan there. So the opposite would be y, and the adjacent would be x. In this particular case it's y1, x1, but in general it's y over x, and opposite over adjacent, y over x. Now remember, if you look above, y1 is the same as sine theta, and x, or x1, is the same as cos theta. So tan is sine over cos, if you want to put it briefly, sine theta over cos theta. We've seen that before. So what happens if we go to quadrant 2, that was quadrant 1, now quadrant 2, so some angle that's in quadrant 2, so it would be a different scenario. So the radius arm would be somewhere over there, and we've got a different point. Let's call it, the point P now is actually over here, and it's got different coordinates, which we might just call xy, but it's going to have to be called x2, y2, okay, because it's the second point. And we've got now an angle, but it's quite a lot bigger. It's actually greater than 90, so it's obtuse now. And I've just spotted an error. You might have seen that at the beginning. That should say 90 to 180. That's what an obtuse angle is. Okay, apologies for that. But we are looking at all angles between 0 and 180, but it is correct to say that obtuse angles from 90 to 180. Okay, sorry, just a bit of clarification there. Apologies. So getting back to this unit circle, that big angle we've just traced out there now, we can't use regular triangle trig on that, because, so now that the radius arm is over there, this angle is not going to allow us to have a right angle triangle. It won't allow a 90-degree angle. If you think about that, because that's going to be bigger than, you can only have one 90-degree angle in a triangle, so that angle there is already bigger So it won't, let's say it's 150, it'll only have 30 degrees. You can't fit a right angle in that, so that it won't be right angle, and we have to address that by thinking of a different way of doing things for the second quadrant, for obtuse angles. I have to use an idea sometimes called a reference angle or a related angle. So reference angle is something that allows us to relate. There's that word relate. It relates it back to the first quadrant. And the good thing about the first quadrant is we can use our regular trig because the angles allow for a right angled triangle. So that's why we do it. We just take quadrant 1 and quadrant 2 off this unit circle and put them further down the page. So I'm just going to isolate them and put them further down here. My stylus is not letting me write. There we go. And I'll recreate that bit for you. So just drawing quadrant 1 and quadrant 2 alone down here, what do we do for, the question was, what do we do for the big obtuse angles? How do we find those values using the unit circle? Because we're going beyond 90. And going beyond 90 degrees means we can't use regular sine, cos and tan, triangle, trig. Well, let's have a look at that using an example. If we have in the first quadrant here, going back to quadrant 1, if we have just in here, going back a step, if we had an angle there, and let's say if that equals 45 degrees. And we know from our exact values that we've got these values from what we saw previously, and remember they come from a type of triangle we used. It was an isosceles triangle of 45, 45, 90 angles, and 1, 1 and root 2 for the hypotenuse. That's from a previous bit of work we did. And you can see the values for sine, cos and tan we achieved last time in that table that's just popped up. So what would it be if we had, say, 135 degrees? Well, 135 degrees is obtuse, okay? And what would it be? Well, it would be 135 there, but 135 is 180 take 45, and we've got some information about 45, so maybe we can use that, and that's the idea of what we're doing here. So to take off the 45 means we've got the 45 happening in here, and we can put in our little right angle triangle in this part here. The radius is in the same spot, and it's still pointing to these coordinates, and the x and y values are still the same, so we can use actually this little triangle, and we've got the same angle theta there, and that's why it's called a related angle. And so when we find sine of 135, we're really finding sine of this one in here. It'll give us the same answer, and so we've got an easy job to do because sine is opposite over hypotenuse, and so let me just get that in a good spot. Opposite over hypotenuse. So if we get to that turquoise angle, the opposite is the y value. Now remember, on 45 degrees it's 1 over the hypotenuse root 2. Cosine is adjacent over hypotenuse. Now it's -1. Okay, it's going in the negative direction, so it'll be -1 over root 2. Okay, because we're on a Cartesian plane, and so it's heading in the negative direction, and tan is opposite over adjacent, which is opposite is 1 and adjacent is -1. So what do we notice here? We notice a pattern. The sine values came out the same in the second quadrant. Cosine, one's a negative of the other, and the tan one's the negative of the other, and that's why we say that is quadrant S. We label it S because only sine is positive in quadrant 2, whereas all of them are positive in quadrant 1. And eventually we're going to work up to what's called ASTC. We haven't started on those bottom quadrants in this video, but we have looked at these two. So what we found in this investigation was sine 135 is the same as sine 45, cos 135 is the same as the negative of cos 45, and tan 135 is the same as the negative of tan. So only the sine value stayed positive. The others went from positive when you use 45 to a negative value when you use 135. So cos and tan values are negative in quadrant 2, whereas sine is positive. So the thing to take away from this now, in general, in quadrant 2, so we're looking between 90 and 180 degree angles. So they're those obtuse angles. So if we've got an obtuse angle involving sine, so that would be called sine of 180, take that little related angle, that will equal just sine of the related angle. So sine of 180, take the acute related angle, will just equal the sine of the related angle, or if you prefer, reference angle. So if we have cos of 180, take the reference or related angle, it's equal to the negative of cos of the reference angle. And lastly, tan, the same story. So tan of 180, take the reference angle, is negative tan of the reference angle, also known as the related angle. So that's your takeaway there, and that's why they call quadrant 2 S, because only sine is positive